Can India's GDP maintain a steady growth rate in the face of mounting challenges? This question has been a subject of heated debate amongst economists and policymakers alike. The Indian economy, once a beacon of rapid growth, now grapples with a series of issues that threaten its upward trajectory. The aftermath of the COVID-19 pandemic has left an indelible mark on the economy, but it's not the only challenge. Rising petroleum prices and high unemployment rates have further strained the economic fabric of the nation. But how do we navigate through these turbulent times? The answer lies in long-term GDP forecasting. This method allows us to draw predictions about the future of the economy. However, it's not as simple as crunching numbers. There are many variables at play and exogenous shocks to consider. Let's delve into the complexities of long-run forecasting to understand why it's not as straightforward as it might seem. Forecasting long-run growth is a challenging task due to two key reasons. Our journey into the complex world of long-run forecasting begins here. Firstly, we encounter the unavailability of a robust methodology. Those well-versed in the art of predicting economic trends will be familiar with models such as autoregressive and moving average process, vector autoregression, and vector error correction. These methods, while popular, rely on a limited number of variables to maintain enough freedom for reliable inferences. But here's the rub. Limited variables mean limited information. They may overlook vital elements that play a dominant role in the dynamics of macroeconomic variables like GDP. Our second challenge: dealing with unobserved exogenous shocks and policy variables. These are factors outside of our control that can impact the economy, such as rising temperatures or changes in oil prices. Traditional econometric methods often overlook these elements, missing out on a vast set of information. It's like trying to solve a jigsaw puzzle with half the pieces missing. So where does this leave us? Well, due to these limitations, there's a growing interest in using high-dimensional big data. This approach attempts to capture as much information as possible for forecasting macro variables. Imagine having every piece of the puzzle at your disposal, providing a clearer and more comprehensive picture of what the future might hold. But don't be fooled into thinking this is the magic bullet for all our forecasting woes. Using high-dimensional big data brings its own set of challenges. It's like navigating through a dense forest with no clear path. More data can mean more noise, which may reduce the precision power of our economic models. So it's clear that long-run forecasting is not a walk in the park. It's a complex task, requiring a delicate balance of methodologies and the ability to handle exogenous shocks and policy variables. And while high-dimensional big data offers a promising avenue, it's not without its own set of hurdles. The adventure of long-run forecasting continues. High-dimensional big data can capture a vast amount of information, but its use comes with challenges. That's the crux of our third scene today, as we delve into the role of high-dimensional big data in forecasting macroeconomic variables. High-dimensional big data is like a treasure trove of information. It's like a sprawling library with thousands of books, each containing a unique piece of the puzzle. When we talk about forecasting macroeconomic variables like GDP, this data can provide us with insights that might otherwise be overlooked. It captures not just the primary factors, but also the secondary, tertiary, and even quaternary factors that influence these variables. It's like having a bird's-eye view of the entire economic landscape, allowing us to see the intricate web of connections and dependencies that traditional econometric methods might miss. However, like navigating through a vast library, using high-dimensional big data comes with its own set of challenges. The primary one being the potential reduction in the precision power of econometric inferences. Imagine trying to read all the books in a library. It's an overwhelming task, and you might lose sight of the big picture. Similarly, when dealing with high-dimensional big data, the sheer volume and complexity can lead to a reduction in the precision of our inferences. It's like trying to hear a soft melody in the middle of a bustling crowd. The noise can drown out the melody, and in the same way, the volume of data can drown out the precise insights we're looking for. This is especially true when forecasting long-run growth. The further we try to look into the future, the more variables come into play, and the more complex the data becomes. It's like trying to predict the plot of a book based on the first few chapters. There are so many twists and turns that could occur, and each one could drastically change the outcome. So how can we address these challenges to make accurate long-run forecasts? The answer lies not just in gathering more data, but in refining our methods of analysis, in understanding the nature of high-dimensional big data, and in developing robust models that can effectively sift through the noise to find the melody. The future of India's GDP growth depends on strategies to deal with these challenges. Facing the complexities of long-run forecasting, India must navigate through the uncharted waters of exogenous shocks and a dynamic economic landscape. These challenges, however, aren't insurmountable. They require a calculated and strategic approach. Firstly, dealing with exogenous shocks is paramount. These shocks, such as rising temperatures and fluctuating oil prices, can derail economic progress. India must adopt strategies that not only mitigate these shocks, but also leverage them to its advantage. For instance, the threat of rising temperatures could be turned into an opportunity by investing in green technologies and sustainable practices. This could spur innovation, create jobs, and stimulate economic growth, all while addressing the urgent issue of climate change. Secondly, public investment is pivotal to India's long-run GDP growth. Investment in sectors like infrastructure, education, and healthcare can act as a catalyst for economic growth. Infrastructure development can create jobs, boost productivity, and enhance the country's competitiveness. Investment in education and healthcare, on the other hand, can foster a healthier and more skilled workforce, the backbone of any thriving economy. Moreover, the delivery of public services plays a crucial role. Efficient public service delivery can ensure that the benefits of growth reach all sections of society, thus promoting inclusive growth. It can also enhance the quality of life, fostering an environment conducive to economic activity. These strategies are not just about maintaining a steady GDP growth rate. They are about transforming the very fabric of the Indian economy, making it resilient, inclusive, and sustainable. They are about harnessing the power of high-dimensional big data to make informed decisions that shape the future of India. This journey won't be easy. It will require political will, economic foresight, and a collective resolve. But the rewards are immense. A prosperous India where growth is not just an abstract number, but a tangible reality felt by all. The path to a prosperous future for India lies in overcoming these challenges and making accurate long-run GDP forecasts.